In this video, we're going to look at evaluating trig functions for non-acute angles. So when we're dealing with a non-acute angle, so an obtuse angle or even larger, we're going to use something called a reference angle. A reference angle for theta, written as theta prime, is a positive acute angle made by the terminal side of angle theta and the x-axis. A reference angle is always positive and between 0 and 90 degrees. Now, what we'll use for those, we'll use reference angles because if you remember from that last video, we have a nice table of all the trig function values for those acute angles between 0 and 90 degrees. First, let's just practice finding reference angles. So if we have an angle of 218 degrees, now 218 is a positive angle measure, so we're going to measure counterclockwise. So 90, 180. The next, that negative y-axis would be 270, so we're somewhere in here. There's 218 degrees. Our reference angle is the positive angle measure between the terminal side and the x-axis. It doesn't matter if it's the positive or the negative x-axis, just the x-axis. So here is our reference angle theta prime. Now to find theta prime, what we're going to do is we're going to take the 218 degrees, that pink angle, and we're going to take away 180. So again, if we have this entire angle and then we take away that straight angle, we're going to be left with just theta prime. So our reference angle for 218 degrees is 38 degrees. What if we have an angle of negative 1,280 degrees? This is a very large angle. What we're first going to determine is a coterminal angle. So I'm going to look for a positive coterminal angle. So negative 1280. I'm going to add multiples of 360. I'm going to go ahead and add 3 multiples of 360. Just to see where this gets me. I don't want to just keep adding 360 because it's going to take me a while. Negative 1280 is pretty far from 0. So if I look at negative 1280 plus 3 times 360, I get negative 200. Well, I'd still prefer to have an angle that's positive. So I'm going to add one more 360 degrees. And our coterminal angle is 160 degrees. So again, measuring out theta is equal to 160, or rather the negative 1280. Negative 1280, we're going to have to go around the circle, and I'm going to draw this and then erase it. I'm going to have to go around 1, 2, 3, 4, and then go another 200 degrees. There's 90, there's 180, there's 200, landing me right about there, which is the same as starting here and going to about there. So we end up with that same terminal side. From here, we can find our reference angle, theta prime, that angle between the terminal side and the x-axis. Now to find this reference angle, what we're going to do is take 180, and we're going to take away that 160 degrees. So our reference angle for negative 1,280 degrees is a 20-degree angle. So this image over here, this little picture, organizes how to find your reference angle depending on where that terminal side is located. I'm going to start with this First quadrant, if your terminal side is in the first quadrant, your reference angle is equal to your angle. They're the same. If you're in quadrant 2, to find that reference angle, and this is just like the example B we just did, we're going to take 180 and we're going to subtract theta. If that terminal side is in quadrant 3, we're going to take theta and subtract 180. That's similar to what we did in example A. And if we're in quadrant 4, we're going to take 360 degrees and we're going to subtract theta to find our reference angle. So using reference angles, we can determine exact values for trig functions without having to reference a calculator. All we need to know is our reference angle, which tells us the special right triangle that we're going to be working with and what quadrant it lies in, so we know what sign the trig function value should be. We're going to find the 6 trig function values for 210 degrees. So I'm going to start by sketching a picture of 210 degrees. So 210, there's 180, somewhere in here. So there's theta. The blue is our reference angle theta prime. If our terminal side is in quadrant 3, to find that reference angle, we're going to do our angle minus 180. So 210 minus 180. Our reference angle is 30 degrees. We also know that we're in quadrant 3, so only tangent and cotangent are going to be positive. So we're going to use that 30-degree special right triangle to find our trig function values. And then knowing that we're in quadrant 3, we can assign the appropriate sign for each of those values. So sine of 210 degrees. Again, we're referencing back to this table. Okay, so you might have to flip back to your pages. I can't have them both displayed on the same time. Sine of 210 is going to be negative 1/2 because, again, only tangent and cotangent are positive. Cosine of 210 degrees, and I'm looking at that 30-degree row in that table. Cosine of 210 degrees is negative square root of 3 over 2. Tangent of 210 degrees is equal to square root of 3 over 3. Again, tangent's positive because we're in quadrant 3. Cosecant of 210 degrees is going to be the reciprocal of sine, so negative 2. Secant of 210 degrees, negative 2 square root of 3 over 3. And cotangent of 210 degrees is the square root of 3. Find the function values for your 6 trig functions using angle theta is 675. We're going to again start with finding a coterminal angle, just so we're not dealing with such a large angle. So I'm going to start by subtracting 360 degrees because 675 is not that big, and that gives me 315 degrees, which is between 0 and 360. So as long as we're between 0 and 360, we don't want to go any further by adding or subtracting, in this case, multiples of 360. Because it's coterminal, we know that how do I want to write this? all of our trig function values of 675 degrees are going to be equal to the trig functions for 315 degrees. So they're not the same angle measure, but we can use that replacement when evaluating trig functions. So 315 degrees, 90, 180, 270, 315 is going to be somewhere over here in the fourth quadrant, which makes this angle theta prime our reference angle. Theta prime is going to be 360 degrees minus that 315, or 45 degrees. So now if you're looking at that other table, we're looking at that 45-degree row for those special, the trig functions for that special angle. Now, because we're in quadrant 4, that means only cosine is positive. Or secant. So sine of 675 degrees is going to be equal to negative square root of 2 over 2. Cosine of 675 degrees is equal to positive square root of 2 over 2. Tangent of 675 degrees is equal to negative 1. Cosecant of 675 degrees is negative square root of 2. Secant of 675 degrees is positive square root of 2. And cotangent of 675 degrees is negative 1. Use the function values of special angles to evaluate. So we want to find 2 times tangent squared of 120 degrees plus 3 times tangent squared of 150 degrees minus cosine squared of 180 degrees. So I'm going to start by just quickly sketching 120, 150, and 180 degrees so that I can identify my reference angles and then use that chart that we have for the trig function values for our reference angles. 120 degrees, here's 90, 120 is going to terminate in that second quadrant. And there's our reference angle. In this case, our reference angle, if theta is 120 degrees, our reference angle is going to be 180 minus 120, or 60 degrees. So we can use that row for 60 degrees for trig function values to evaluate something that is measured at 120 degrees. 150 degrees, still in that second quadrant, but a little bit further over. And theta prime is going to be found the same way. So if theta is 150 degrees, our reference angle is going to be found by taking 180 minus 150 degrees, or 30 degrees. This is a great opportunity for me to explain that a lot of times when I'm drawing these pictures, they are intended to be a sketch just to help my brain process how to find other values. So looking at these, it's almost non-differentiable between 120 and 150 degrees. Obviously, they do have different measures. But my pictures will never be perfect, and I don't expect yours to be perfect either. But there is a difference between having a good approximation and a bad approximation. So it is important that we are illustrating that 120 and 150 degrees both lie in the second quadrant. And then 180 degrees, our reference angle is 0. But we're not going to need a reference angle for that because this is a quadrantal angle and we have a chart for that as well. So tangent of 120 degrees, well, let's think about our signs here. In the second quadrant, tangent is going to be negative. So this is going to be a negative value. And then we look at what is tangent of 60 degrees. Tangent of 60 degrees is the square root of 3. So this is the negative square root of 3. And remember, tangent squared of 120 degrees is the same as saying take tangent of 120 degrees and square it. Plus 3 times. In the second quadrant, tangent is still negative. So this is going to be negative. And now we're looking at what is tangent of 30 degrees? Because the reference angle for 150 is 30. And tangent of 30 degrees is the square root of 3 over 3. Again, squared. And then cosine of 180 degrees. If we look at this picture, cosine of 180 degrees is actually going to be -1. So now that we've substitute those values in using our reference angles and the appropriate signs based on the quadrant of our terminal side, we can start simplifying. Negative square root of 3 squared is going to be 3. The negative square root of 3 divided by 3 squared, we're going to square the numerator and the denominator, so we get 3 over 9. And -1 squared is 1. So we've got 6 plus 3 times 3 over 9 is 9 over 9, or 1 minus 1. So this expression simplifies to 6. I would like to add, and I've mentioned the unit circle quite a few times, we are going to get to the unit circle in Unit 2. But once we know the unit circle, we'll start introducing some new techniques that don't require us to have these tables memorized. So I promise you right now we're using them as a quick reference because we haven't quite built up completely to the unit circle. But once we've established that unit circle and we start learning some of the properties and some of the patterns within the unit circle, a lot of these are going to be maybe feel a little bit easier to figure out without having to constantly reference a table. And this is going to be really good as you move into a calculus course where we need to figure out these function values very quickly and without a calculator. So another similar example, we want to find sine squared of 225 degrees minus cosine squared of 270 degrees plus tangent squared of 60 degrees. All right, so starting with theta is equal to 225 degrees, 90, 180, somewhere in that third quadrant. So if theta is equal to 225 degrees, theta prime is going to be 225 degrees minus 180. That's going to be 45 degrees. $270, that's a quadrantal angle. So we don't need to use a reference angle for that. We know those trig function values. And 60 degrees is going to be in this first quadrant. And when our angle is in the first quadrant, we do not need a reference angle either because the reference angle is equal to our angle measure. So to find sine of 225 degrees, when we're in the third quadrant, sine is negative. So it's going to be negative whatever sine of 45 degrees is, which is square root of 2 over 2. And this value is being squared. Cosine of -270 degrees Again, thinking about this terminating side, that negative y-axis, cosine is going to be 0 here. And then tangent of 60 degrees, tangent of 60 degrees is the square root of 3, and we are squaring that. Now we can simplify. Negative square root of 2 over 2 squared, we're going to square the top and the bottom. Because it's negative, when we square it, it becomes positive. So we have the square root of 2 squared is 2 divided by 4 minus 0 plus the square root of 3 squared is 3. 1/2 plus 3 is 7 over 2. Determine if the following equations are true or false. Sine of 30 degrees plus sine of 60 degrees is equal to sine of 30 plus 60 degrees. So this is a really common, or these are both some pretty common properties that we'll see. We can use those trig function values as special right triangles. So sine of 30 degrees is 1/2. Sine of 60 degrees is the square root of 3 over 2. And this is sine of 90 degrees. Sine of 90 degrees, again, that's our quadrantal angle. Terminating at the positive y-axis is 1. Which is not equal to 1 plus the square root of 3 over 2. So this equation or this statement is false. Sine squared of 30 degrees plus cosine squared of 30 degrees equals 1. Sine of 30 degrees is 1/2. So this is 1/2 squared. Cosine of 30 degrees is square root of 3 over 2. This is also squared equals 1. 1/2 squared is 1/4. Plus, squaring square root of 3 over 2, we get 3 over 4. And 1/4 plus 3/4 equals 1. So this is true. Now, I also want to point out, this is the same as sine squared theta plus cosine squared theta equals 1. This is our Pythagorean identity that we introduced a couple of videos back. So now we've seen a concrete example of why that Pythagorean identity is true.